All right, this is section 10.2 on density. You may be familiar with density concepts from your science classes, and it's not any different today. So density is just a measure of the amount of something per a specific unit of area or volume. It's how closely packed together stuff is. So we're going to first start with the focus on area densities, and then in a minute we'll switch to volume densities. But first with area. So density is just going to be the amount of something divided by the total area that that stuff is occupying. Um, the numerator there, the amount of something, it can be a lot of different things. It can be the number of people, it can be the number of fish, it could be trees, it could be anything, just how many of that thing you have. And then that's divided by an area. So area, sometimes it's pretty obvious that something is an area, like if it's centimeters squared or inches squared or miles squared. Power 2 indicates area on units, but there are some area units that don't have that power 2 that you should just be aware of and to watch out for. Like an acre, we measure land in America by acres or acreage, so that is an area without that power 2. It just is a square unit. In metric, sometimes you'll see a hectare. So we're going to first talk about population density. So in 2017, Utah had a population of 3.1 million people, and Utah occupies an area of 84,899 square miles. I want to know, what's the population density of Utah? So again, density is the amount of something. In this case, it's going to be the amount of people, and it's divided by the area that those people occupy. So for the case of Utah, that will be 3,100,000 or 3.1 million people. And we're going to divide that by the area of Utah, 84,899 square miles. So if we divide that, we find that Utah has a density of 36.5 people per square mile. In densities, you're always gonna, or with densities, you're always gonna have units like this: people per square mile, trees per acre. It's always got that per in it because density is how much per this area. And in the case of population density, it's kind of like an average. So that's saying, you know, if you took all those people in Utah and you spread them out thinly, like spreading frosting on a cake, if you spread those people out, there would only be 36.5 people in each square mile. That's a pretty low population density, especially compared to places like back east. A lot of the western states have lower population densities. Monaco is a small country on the Mediterranean coast, teeny tiny country. It only occupies an area of 2.02 square kilometers. So here is our area. It happens to be the most densely populated sovereign state in the world, and it has 19,009 inhabitants per square kilometer. This number right here, inhabitants per square kilometer, that is giving you the density. We want to calculate the population of Monaco. So we're going to use the same idea of density, but this time we're solving for something different. Remember, density is the amount of something divided by the area. Well, the things that we know in this case is we know the area and we know the density, we're going to be solving for the amount of people. So in our equation, that's going to be our x. We don't know that. So if we set up our equation, the density goes in that first position, 19,009 people per square kilometer. We don't know how many people it is. That's what we're trying to solve. But we do know the area is 2.02 square kilometers. So to solve for x in this case, we've worked with these sorts of equations before that have fractions in them. We want to multiply by the denominator. So we're going to multiply both sides by that 2.02. Whoops, I don't know why I crossed that off, sorry. And that will give us the answer for the population. So they have 38,398 people. So it's a very small country. It doesn't have a very big population, but those people are packed in tight. There are 38,398 people living in that tiny space of 2.02 kilometers squared. The whole country is basically one big city. All right, here's one to try. During an experiment, some bacteria are grown on these two petri dishes. Petri dish A is a smaller petri dish. It only has a diameter of 51 millimeters. And about 40,000 bacteria are living there after an hour. Petri dish B has a diameter of 75 millimeters. After an hour, it has about 72,000 bacteria living on it. I want to know which petri dish has a greater density of bacteria. Obviously, dish B has more bacteria, but our question is which one has a greater density of bacteria. So again, to calculate density, we need to know how much bacteria are going to live in how much area. We've got to divide it by the area. So we have circles here. Petri dishes are circles. So to calculate the area, we use the equation pi r squared. And in this case, the diameter is 51 millimeters. So the radius from the center to the edge would just be half of that, 25.5 millimeters. So this will be 25.5 squared. And if we calculate that, we come up with an area for that petri dish of 2,042.8 square millimeters. So we can calculate the density for petri dish A now. We know there are 40,000 bacteria living there, and they occupy a space of 2,042.8 square millimeters. And if we calculate that density then, we get that there are 19.6 bacteria per each millimeter square. So that's the density for dish A. Sometimes when we're working with two quantities and we want to compare them, we'll put like a label with that variable. So this is the density of dish A. And put the little A there. That will just remind us that that one goes with A. In this case, you know, because of the way the board is organized, you can tell that that stuff goes with A. So for dish B, we'll do the same thing. We are going to take the amount of bacteria, and we're going to divide it by the area for petri dish B. Well, in this case, the radius is going to be half of the 75 diameter, so 37.5. So if we calculate the area using pi r squared, it's going to be 4,000 417.9 square millimeters. Okay, so for our density, in this case, the amount of bacteria is 72,000 bacteria, and the area is 4,417.9 square millimeters. And the other one was the density of dish A. I'm going to put a little b here to remind me that this is the density of dish B. And we calculate that to be 16.3 bacteria per square millimeter. So our original question was, which Petri dish has a greater density? Well, in this case, the one with a greater density is going to be dish A. It has like 3 more bacteria per square millimeter than dish B, so a higher density. All right, so those were area densities. This one does not have an exact numerical answer. These next two we're just going to be thinking about concepts of density and not calculating anything. So these two islands shown, they have their areas on display right there. They have the same population. Which one has a greater population density? And how do you know that? Well, hopefully you'll maybe think about this for a second, but remember that density is the amount divided by the area. So if this is a smaller number, if it's a smaller area like this orange island, that means you're dividing by a smaller number, which makes the density bigger. If the area is larger, a larger number, that means we're dividing by a larger area. That's going to make it have a smaller density. And that really makes sense if you think about it. If you had a bunch of people on this island, they could, you know, if you had the same amount of people, these ones would have to be closer together. And these ones could spread out more. And that's kind of what density is a measure of, is how spread out things are, especially with area densities. This first island, the orange island, would definitely have a higher density. Those people would have to be living closer together. Okay, last one with area densities. One of these is not a good density. The other three are beautiful densities. So which one of these doesn't belong with the other three? We have bears per square mile, video gamers per city, people per square kilometer, and trees per acre. Hopefully you have identified that it is this one. Video gamers per city. The reason this one is not so hot is because a city is not a measurement. We don't know how big the city is. It doesn't really tell us about the density of the video gamers. If it was a small city and it was a lot of video gamers, that would be a high density. But if it was a big city, it might be a lower density. We got to know the size of the city. It can't be ambiguous like that. Miles is a measurement. Kilometers is a measurement. Acres is a measurement. City is not. Okay, so we're going to switch now to volume densities. They work essentially the same way. It's just that we're trying to figure out not the density of the area, but the density that's filling a 3-dimensional space instead of a 2-dimensional space. So the formula though and everything works the same. We're just going to be dividing by a volume now instead of an area. The volume, when you watch out for volume here, you know, you'll see that third power to indicate that it's a 3-dimensional volume. But there are some less obvious measurements of volume that you have to watch out for. A big one would be gallon. That's a volume. liter in metric is a volume, quarts, fluid ounces, those are all volumes. So sometimes when you have a problem dealing with one of those less obvious units, you may get stuck to trying to decide, you know, is that a numerator or a denominator? Is a gallon an amount of something or is it a volume? Gallon is a volume. So we're going to go through a few examples with volume densities. First is a wooden cube. Wooden cube has an edge length of 6 centimeters and a mass of 137.8 grams. I want to know the density of that cube of wood, and we want to figure out which type it is using this density chart. Different types of wood have different densities, so if you know the density, you can kind of tell which type of wood it is. So if we think about our formula, the density is the amount of something divided by its volume. A lot of times with volume densities, the amount is the weight or the mass. It doesn't have to be that in a math context, but it often is. In chemistry, when you calculate densities, it's almost always a mass in the numerator. So in this case, that amount of stuff we have is 137.8 grams. And we're trying to calculate the density, so we need to divide that by the volume. Well, what we know is that it's a cube that has an edge length of 6 centimeters. So it has a length, a width, and a depth of 6 centimeters. So that shape is pretty easy to calculate the volume of. The volume would just be 6 times 6 times 6, and that's going to be centimeters to the third power. So that's 216 cubic centimeters. So if we crunch that and calculate the density, it's going to be 0.638 grams per centimeter cubed. And again, with density, you'll always have some sort of unit like that with grams per. You'll see that word per and then a volume. So if we look at our chart over here, we can tell that we have a cube that is made of ash. All right, this diagram shows a standard gold bar at Fort Knox. Gold happens to have a density of 19.3 grams per centimeter cubed. A lot of metals and everything, they have a very specific density. They don't really vary. So we're going to use that density of gold that we know to figure out how much it weighs, what the mass is in grams. If you're using density, which we're going to use the density to calculate something, the units can tell you how to set it up. So if we're setting up our equation, the fact that the density is 19.3 grams per cubic centimeter is telling us that the amount is going to be measured in grams and the volume is going to be measured in cubic centimeters. And it tells us specifically that the grams are going to be on top and that the cubic centimeters are going to be in the bottom. So you can use the units to kind of help you set it up if you're confused for a minute. So we need to know the volume of this thing. And it's a rectangular prism, so we're just going to times those three dimensions together. 17.8 centimeters times 9.2 centimeters times 4.4 centimeters. And I get 720.544 cubic centimeters. So that goes here in our equation. Okay, and we're trying to solve for x, so we times both sides of our equation by that 720. And that tells us that we have a mass of 13,906.5 grams. I think when I calculated that, and I might be misremembering, but I think when I calculated that earlier, it was about 6 pounds, but I could be misremembering. Okay, the density of American white oak is 47 pounds per cubic foot. If the trunk of an American white oak tree has a circumference of 14.7 feet and the height of the trunk is about 26 feet, I want to know what is the weight of the trunk. So if we're thinking about trees, we've got this really quite big tree. It's still alive. It's not cut down. We want to know about how much does that trunk weigh. Well, the things that we can measure are, we can measure the height. It is 26 feet tall, that trunk. And we can measure fairly easily the circumference of the tree, and it's 14.7 feet. This is a really big tree. I want to calculate the weight of the trunk, so we're going to use the density formula, and we're going to put that weight in the numerator and the volume in the denominator. Well, we know the density, that's told to us. The density is 47 pounds per cubic foot. The weight is what we're trying to calculate, and in order to use this equation, we have to calculate that volume. Now, if you think about a tree trunk, the shape of it is that it's a giant cylinder. We have the height of that cylinder. We need to know, in order to calculate the volume of the cylinder, we need to know the radius. And, you know, when a tree is alive, it's quite difficult to calculate that radius, but it's not so difficult to calculate the radius given the circumference. You can easily measure that circumference. So the formula that relates circumference and radius is that the circumference is 2 pi times the radius. Well, we know the circumference is 14.7, and we want to know what the radius is. We can simply divide by 2 pi. Now, if you're using a graphing calculator, you need to group that or it will miscalculate. It'll times by pi instead of dividing. But if you do that, you should get that the radius is 2.34 feet. So we can calculate the volume. The volume is, this is a cylinder, so it's pi r squared times the height, circle times the height. The radius was 2.34, and the height was 26 feet. And so if we calculate that, we get a volume of 447.3 cubic feet. Now that's going to go into our equation here. So to solve this one, much like some of the other ones we've done, we'll just multiply by that volume. And we end up with 21,023.1 pounds. So that's a big tree. It weighs a lot. That's like 10 tons. Very heavy. Very huge though, 26 feet tall. All right. For the purposes of the video, I'm going to skip this last example. here's just your summary. Density is, it's just the amount of something you have per a specific unit of area or volume. The assignment is in your note packet if you have the note packet, and answers are at the back so you can check your work. If you get stuck on any of those, bring it in and we'll talk about it in class. Thank you.